Let's take a second to think about the idea of unit rates. So suppose a rabbit runs at a constant speed of 4.15 feet per second. We're going to let t represent the number of seconds since the rabbit started running, and we'll let d represent the number of feet the rabbit has traveled since it started running. So this idea of running at a constant speed of 4.15 feet per second, this unit rate of 4.15, there's two important ways we can think about this. The first one is each second that passes, the rabbit travels 4.15 feet. And this might be what your gut tells you to think about 4.15 feet per second. But it's also true that the distance the rabbit traveled, d, is always 4.15 times as large as the number of seconds, t, since it started running. So two ways of thinking about this, they're both certainly true, but one of them is a little more powerful than the other. So if we think about situation A, each second that passes, the rabbit travels 4.15 feet. But if that's the only way we think about this, then over here on the left, if we think about the graph of d in terms of t, then we're only thinking about t changing by 1 unit at a time. So as t increases, it just jumps by values of 1. But if you think about that, our graph looks very incomplete, and what that means is 1 second chunks just pass, which would be like the rabbit teleporting each second. And so this isn't really a very powerful way of thinking about this because it tells us nothing about what happens for non-integer values of t. Like, what about when t equals 4.3? Or when 5.47 seconds have elapsed since the rabbit started running? This first way of thinking about it doesn't do much work for us. On the other hand, part B tells us that d is always 4.15 times as large as t. And this is going to be true for any value of d and t. So we can actually imagine time elapsing continuously, so how the world actually works. And as t increases continuously, or time elapses continuously, d also varies continuously so that it's always 4.15 times as large as t. So our graph gets graphed out like this, which looks like a better representation of how the distance traveled and time elapsed varies as the rabbit travels. Now it's important to point out that in the second way of thinking, it actually kind of encapsulates the first one. If d is always 4.15 times as large as t, if t is equal to 1, then d must be equal to 4.15 times 1, which is 4.15, which is pretty similar to the first way of thinking up there, about 4.15 feet each second that passes. So, although you might have experience thinking in terms of this first way of thinking, we encourage you to start thinking about unit rates in this second way down here. It's a more powerful way of thinking about it, and it gives us a better tool for reasoning about two quantities varying together continuously.